One of my favorite things to do on the weekends is to get out and ski. This year's snowpack is a little bit meager, which makes it difficult to ski some of the steeper terrain. You have roots and rocks sticking out, but nonetheless, it's great to get out there and put in the turns. The difference between a good year of snow and a bad year of snow in the Colorado Rocky Mountains doesn't just affect the ski industry, it also affects water resources. Some areas around the world get their water by drilling down through rock layers, and within the rock layers there are cracks and fissures where water settles. This water is then brought to the surface and then can be used. This water can be thousands of years old. In other areas, people depend on fresh water to fill their reservoirs. But in Colorado, you have snow blow up onto the Rocky Mountains, tons of snow, but then on the backside of the Rocky Mountains there isn't any more moisture left, and you're left with a rain shadow by Denver, Colorado Springs, and Fort Collins. These areas depend upon the snow thaw within the spring and the early summer for their water supply. Without it, there wouldn't be any cities. Right now it's too warm for skiing, and we're in the rain shadow of the Colorado Rockies. We're going to start talking about water resources on a more specific scale. We're here at a water treatment plant in the Colorado Front Range. Let's figure some stuff out. Hey Steve.
Hi Ryan.
Nice to see you.
Nice to see you.
This is Steve Foley. He's the water treatment plant supervisor, and he's going to give us the rundown on what happens in water treatment plants in the Colorado Front Range. What percentage of the water that we drink comes from up in the mountains?
100% comes from the mountains. It all starts in the mountains, runs down the hill, and then ends up in reservoirs, which we take water out of to treat for human consumption.
So we have a lot of water coming out of the mountains, the thaw of the snow, and it comes down here. What's it mostly used for?
Predominantly in the winter, it's used for indoor uses such as showers, drinking water, toilets, clothing. In the summer, a lot of it's used for irrigation, such as parks and rec, front lawns, etc.
But we're a huge part of the agricultural community. How much of the water that comes out of the mountains is actually used for agriculture?
So drinking water, the water that we treat, does not go to agriculture.
The water coming out of the mountains is crystal clear. That's at least what people think. Is that right?
The water we have coming down from the mountains is very, very clean. We're very lucky to be in the location that we're at the foot of the mountains. But it's not crystal clear. There are particulate matter in there. There is dirt, biological matter that we need to remove.
Can we take a tour of the water treatment plant and see what's going on?
Absolutely.
Cool.
This way.
The room we're in right now seems to be some sort of computer monitoring station. What's going on here?
Well, this is the room where we monitor the water quality 24/7 to make sure that the process is working correctly.
What kind of variability do you see in the quality of water coming out of the streams?
Well, typically it's very good and very consistent, but there are times where it can get upset based on weather events, wind, rain, snow melt.
What do you do with the variability of the sediments?
We adjust the process to compensate. The way we treat the water is we add coagulants, which effectively form floc that then attract dirt and sediments. And we'll change the process by changing the amount of chemical or the way the chemical and dirt interact to remove it.
So this is where the water comes in?
Correct. The water comes in, it runs through these baffles here. We add coagulant to flocculate the water, and then we remove the particulate after it's been flocculated.
Okay, so if you flocculate it, explain it again, because I'm thinking of sands just settling to the bottom. Why do you have to mix it up?
Well, a lot of the material does settle to the bottom, but that usually happens in the reservoirs. What we're doing here is we're removing the solids that won't settle on their own.
Ah, that's really neat. So the reservoir is the beginning of the process, and then from the reservoir it moves here where it's fine-tuned.
Correct.
It looks as though you're adding something into the water that's coming out of the reservoir.
That's correct. This is the first step of the process where the water comes in and we add the coagulant. So this is actually the coagulant that you can see being added here. The coagulant is what forms the flock, which removes the dirt particles.
These devices over here are the coolest things that I've seen in the building so far. What do they do?
Well, these are our saturators. They're basically like big soda cans that we take water and air and pressurize them. And as you pressurize the water and air together, the water takes in the air. So the reason we do that is the next step of this is removal of the particulate that we flocculated.
So based on the fact that this is our next stop after the saturator, and there's also foam like soda on top of this water, I'm guessing this is the next step in the process.
Yes, what happens is the air and water that have been saturated in the saturator comes over here and we release its atmospheric pressure. And when it hits atmospheric pressure, the bubbles just come bubbling out of the water, similar to a soda can. And what happens is having all those tiny little bubbles picks up all the dirt and sediment and flocculate that we've made, and it brings it to the surface for removal.
And that's why this is so disgusting looking. You normally think of water as being kind of clean coming down the river, but what we're looking at here is dirt that's stuck to the bubbles at the very surface.
And this is the vast majority of all the particulate that's in the water.
So we see these brushes moving along over the coagulant. What's going on with these brushes?
These brushes are taking all the residuals that have formed from removing it from the water, and they're taking it into this trough where we remove it from the process.
So you remove it from the process, then what happens to the waste?
Well, then we send it out to dry, and from there it can either go to a landfill or be turned into compost.
So there's multiple uses for the waste that's formed from water. It actually can be helpful.
Yes, that's correct.
That's really neat. So the coagulant hasn't taken out everything from the water. You can look down into this water and actually see particles floating around inside. What happens next to get rid of this so that it is that clean, clear water that everybody wants to drink?
This is the final process where we further clarify the water to make it crystal clear for the consumers. And this is called a filter bed. And the water comes in and then it goes down through the filter, just like a coffee filter, except we use anthracite, coal, and sand and garnet to strain out the remaining particulates.
This is really fascinating. We're looking at pumps that are really small, but they look really important. What happens here?
Well, these are our chemical pumps. These particular pumps feed the chlorine into the water to disinfect it.
Is it towards the end of the whole process?
Yes, this particular one is at the end of the process.
More big pipes, whiny motors. We're in a pump room. This seems like this is where the water is fed from the water treatment plant and goes out. So the holding tanks then to the people.
That's correct. We have 6 high service pumps here. Each one is 250 horsepower and 3.5 million gallons apiece.
This holding tank down here seems to be under some sort of work or construction. Is this routine maintenance?
No, this is actually construction to increase the firm capacity of the facility. We're increasing the production capacity due to maximizing our water rights, population growth, and also climate change.
So this tour's been really cool. We've been able to see how water from the mountains is turned into something that's drinkable. And it seems like you have a really cool job. What do you think about it?
I think it's a great job. There's so many advantages to it, and on top of that, you feel like you're really doing something for the community. You feel like you're providing a product that's important to everyone.
How long have you been doing this?
I've been in the industry about 10 years now.
Wow. Well, I think it's been great, and thank you so much for all your time.
You're very welcome.
All right.